Good morning friends. Today we are going to discuss about stability order of intermediates. In early in previous video we discussed about types of intermediates. They are carbocation, carbanions, free radicals and whatever carbons, nitrates. These all are types of reagents. Today we are going to discuss about stability order. The stability order for them. So here, listen carefully. Carbocation is there, stability. Carbocation means positive charges, species are called carbocations. So here, cyclopropyl rings are surrounded carbocation. So here, 3 rings are there, it is more stable. Cyclopropyl groups are 3 rings are there. Then 2 rings more stable, then 1 group is more stable. But if heptane carbocation is there, it is greater than the 1 ring carbocation. You are getting my points. Coming to this phenyl groups, phenyl group, you know phenyl groups. So this is 3 phenyl groups. So phenyl groups carbocation. Phenyl groups carbocation means 1 phenyl group like this, 1 benzene ring will be there. 1 benzene ring. This is carbocation. Here also 1 benzene ring like this. Here also 1 benzene ring like this. 3 rings are there. 3 rings are greater than 2 rings. So 2 rings are greater than 1 ring. Okay, 1 benzene ring carbocation. So this is commonly known as benzyl carbocation. So greater than this one, tertiary butyl is more stable. Tertiary butyl is more stable. Like this here, 1 ring carbocation is less stable than heptane carbocation. That's like this. It is also same. So then you have to take allyl carbocation. Allyl carbocation after this one. So other than tertiary butyl carbocation is there, tertiary carbocation you have to remember. Next, coming to this point, secondary carbocation, primary carbocation. Then you have to go for CH3 methyl groups. Then you have to go for CH2 double bond. CH2 double bond. This is methyl carbocation. Then benzene ring is there. Benzene is different. Benzyl is different. Benzyl means how can you write like this? Benzyl carbocation. Among benzene, on the benzene CH2 group will be positive charge. This is benzyl carbocation. You are getting my point. Coming to this point, so this is double bond carbocation is more strong than triple bond carbocation. So between this benzene carbocation will be more stable. This is the carbocation stability. You have to remember. Anywhere they will give a question and they will ask the question. Write the increasing order. Okay. Next we are going for carbanion stability. Okay friends, listen. Next stability order, free radical. So before this stability carbocation, you have to go for free radical. So free radical and carbocation is same configuration. I mean sp2 carbons. So same maximum same. So phenyl groups are there. PH2CH is there. PH2CH2 group is there. Okay. This is the line. This is the line. 3 rings, 2 rings, 1 ring. It's okay. Next one, allyl is there as it is carbocation. In carbocation, which one is formed between phenyl carbocation and this one? Phenyl carbocation means this is benzyl carbocation. This is 2 rings benzene carbocation. Between this one, so which one compound is will form? Which compound will be tertiary butyl carbocation is formed. So here tertiary butyl is not given. So we are going this order. Then this one, after this one, allyl is there. Then go for tertiary, secondary, primary carbo free radical. These free radicals are there. So in carbocation between primary and secondary, which one is given? Benzene. Something is there. Okay. You have to remember this order. Next, coming to this methyl free radical is there. Then same order of as it is carbocation stability. Here double bond, triple bond. Between this benzene free radical is there. As it is carbocation and free radical is almost same order. So coming to the carbanion, there is a exception case. Means what is the exception case? In carbanion we will get sp3 hybridization. sp3 hybridization and 8 electrons, electron rich. Okay, carbocation free radical are almost same. Electron deficient to sp2 carbon sp2 hybridization, but it is different. So here double bond, triple bond is there. Triple bond will be more stable. Triple bond carbanion is more stable than double bond, then single bond. Here, double bond will be more stable than triple bond. You are getting my point. So it is quite opposite. Here also listen here, primary, secondary, tertiary. It is quite opposite. But these are same as it is that of like this. Tertiary phenyl, it means 3 rings benzene, 2 rings benzene, 1 ring benzene. So this order you have to remember. So don't forget, these are very important. This stability order. Next we will go for next topic. Next, stability order of intermediates. Stability order of intermediates. Today we are going to discuss about stability order of intermediates here. Over. Next, it is over. Stability order of intermediates. Sorry, it's over. Order is over. So types of attacking reagents. So some reagents will be there. They will attach to any chemical reaction. It means chain reaction, what will be there, carbocation, carboanions will be there. So which types of reagents will be attached to them? So there are 3 types. So number 1 is electrophile, nucleophile, free radical. So electrophile, nucleophile, free radical. So coming to this electrophile, we can write like this, commonly electrophile like this. You are getting my point. Electrophile, E positive. E positive means electron loss or gain loss. So it has electron deficient compound. It has electron deficient compound. So it is positively or partial positively or vacant D and P orbitals, whatever it may be. Almost you have to remember loss of electrons, electron deficient compound species. They attack at electron rich position. So it is due to less number of electrons, electron deficient species, it will always ready to attack electron rich compound. So if any position is, if minus is there, this positive charge is ready to attack with that compound. You are getting my point. Okay. So electrophiles, this is attacking reagents types are electrophile, nucleophile, free radical. So this is electrophile, electron deficient compound. Next to positive or partial positive, vacant EB orbital present. Next to they attack electron rich positions. No, types of electrophiles. Types of electrophiles. Electrophiles means, you know, positive charge, types of electrophile. First one, electrophiles not only looks like positive charge, it will look like positive. So some positive charge compounds will be there. It is electrophile. So some compounds which may be electrodeficient compound will be there. So positive charge electrodeficient will be the same. But here what happens? In some compounds they will show positive charge. In some compounds electron deficient means what? D and P orbitals will be less. So vacant. That's why they will not show positive charge in this position. So if positive charge is not there, we will think this is not electrophile, but it is electrophile. So in this compound, types of electrophiles will be there. Don't say by seeing is positive charge, by seeing positive charge this is electrophile. So you have to observe. First of all, it must and should be electron deficient. So okay, deficient is there. Vacant d orbitals will be there. Vacant d orbitals. Central metal, if a central metal attached to electronegative atom. So if central metal is attached to electronegative atom, it must and should be electrophile. So types of electrophile, each and every example I will give you: positive charge, electron deficient, and vacant d orbital, central atom attached to electronegative atom. You are getting my point? Okay. Coming to this point, now types of electrophiles. First of all, we go for positive charge species. Okay, friends, see here. So electrophiles types are positive charge species, electron deficient compounds. You are getting, you are visible to that one. I will zoom it, don't worry. Are you okay now? Yeah. Okay. Sorry, you can zoom it. Okay, I will looks like that. So these are electrophiles. These are positive charge, electron deficient, vacant d orbital, central atom attached to electron. These all are electrophiles. Don't see by seeing positive charge on the atom. So you can see this one. Positive charge is there, say okay, electrophile. By in this compound SnCl2, ZnCl2 is electrophile. No, it is not electrophile because positive charge is not there. You will say like that. It's wrong. So don't do like that. So positive charge is there. Positive charge means electron is lost. First of all, electron deficient compound. Actually, chlorine atomic number is 17. If you get 18 electrons, it will undergo electronic configuration of argon. So it need one electron, but even though it will need one electron from this one is loose. Cl6 means 16. So it means electron deficient compound. Here also H plus, NO2 plus, positive charge species all are electron deficient compounds. Those are electrophiles. So coming to this group, electron deficient compound, I will show you how can you find out electron deficient compound. Now tell me BF3, write a structure here, BF3 here. How many electrons are there? 6 electrons are there attached to 4. So but how many electrons should be there? 8 electrons should be there. If 8 electrons are there, it is okay. It is what is it? Octet rule configuration. So it is less than electrons. So it is electron deficient, not electron rich. So it is electron deficient. That's why we can call it as BF3. BF3 means how many electrons are there? Third group, second group. Third group is 3 plus 3. Here aluminum is 3 plus 3. Here same third plus 3. 6 electrons are there. But valence should be 8 electrons. Then only we can call it as. You are getting my point. Okay, next. So electron deficient compounds are electrophile. Over. Next, coming to the free radical. Free radical means free radical. Here CH3 free radical will be there. How many electrons are there for this one? Carbon atom 4. Carbon bond, 3 bonds. So 3 bonds, 1 electron is there. Is it electrons? 8 electrons? Now let's see. 6 plus 1, 7 electrons are there. So it is electron deficient. So it is free radical. So free radicals undergoes electrophiles. Coming to the chlorine. Chlorine means what? Actually chlorine is this one. So outermost how many electrons will be there? If bond is formed, then only if negative charge is there, then only it will be correct configuration. 8 electrons. Actually around the chlorine 7 unpaired electrons will be there. 7 unpaired paired electrons will be there. If it get 1 electron from this one, it will get bond. So here what happens here? Only 1 electron is there. Okay. So it needs 1 electron. So electron deficient compound Cl, Br minus, etc. Free radicals all are electrophiles. Okay, over. Positive charge is over. Free radical is over. Electron deficient is over. Coming to the vacant d orbital, SnCl2, whatever it is, ZnCl2, FeCl3. You are getting my point. FeCl3. Is there vacant d orbital? How can you find out vacant d orbital? So we go for FeCl3 example. We go for FeCl3, iron trichloride. So iron atomic number is 26. Iron atomic number is 26 Fe. So coming to the configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6 actually iron for. So oxidation state of iron, what is that? Fe plus 3 na? Fe plus 3 means 2 electrons, 1 electron will be loose. This is the order. D means this one. D means how many orbitals will be there? 5 orbitals will be there. 1, 2, 3, 4, 5. Okay. How many electrons? 1, 2, 3, 4, 5 is there. Unpaired electrons is there. So 3 chlorines will be attached to this one. Vacant d orbitals will be there. Vacant d orbitals are there. So that's why those are electrophiles. SnSO, ZnCl2, FeCl3, FePr3, whatever it may be. Like these are used as Lewis catalyst. The compounds which has vacant d orbitals, they will use as Lewis catalyst. Lewis means what? Lewis catalyst. Lewis acid will be there. Lewis bases will be there. Coming to the central atom attached to electronegative atom. Carbon is a central atom. Oxygen is a electronegative atom. So they will get partially positive or negative. This will get electron deficient compound. CO2, SO3. Oxygen is electronegativity. S is this one. So it means SO3 means how can you write this one? You can write like this. You are getting my point. Okay, SO3 compound. Electron central atom electron. This is all are what is it? Electrophiles. Electrophiles, these are electrophile types of electrophile. We go for next to nucleophiles. Okay friends, coming to the next topic, nucleophiles. So electrophiles is over. For electrophiles is over. Electrophiles means which will one electrophiles? Number one, positive charge. Next to electron deficient, a free radical, vacant d orbitals, and central carbon attached to electronegative atoms. Those are electrophiles. So coming to the nucleophile, nucleophile is denoted by Nu minus. Nu minus means what? Electron rich compound it is. So first one, negative charge species are nucleophiles. So H minus, Cl minus. If H plus is given, electrophile. Cl minus is it. Cl minus is nucleophile. Cl plus is electrophile. OH minus, NH2 minus, NO2 minus, NO2 plus is electrophile. You are getting my point. See, minus charge is those, these all are nucleophile. Okay, you can understand. Negative charge species are nucleophiles and positive charge species are electrophile. Coming to the ampidental nucleophiles. Ampident nucleophiles means what? There are two nucleophilic centers will be there. So the both centers will not participate in reaction, bond formation. Only one center will be formation. I will show you an example. Cn minus is there. Sorry, C minus N, not Cn minus. C minus N. So negative charge present on carbon only. Here negative charge present on sulfur only. Negative charge present on NCS only. So coming to this point here, this is alkyl allied group. So chlorine will be gone away. This will get positive charge. This is positive charge, carbon chain it is. So these are nucleophiles. So Cn minus, suppose if I attach to Cn minus, C minus N. So here lone pairs is there, minus is there. So always minus nucleophile will attach to this carbon. Why? Because minus charge is this one. So attached with the carbon only, not nitrogen. Why? Because negative charge present in this carbon. So that's why Cc strength is more than Cc and bond. Why? Because lone pair is there. The bond formation between lone pair and also possible, but strength is more for between negative charge species. Okay, carbon and carbon nitrogen. Carbon strength is more than carbon nitrogen bond. You are getting my point here. Cn minus Nc will not possible. So this is ambident nucleophile. Okay, these are also negative charge. We can represent it as a nucleophile. Okay. Next, coming to this point, neutral molecules will be there. Neutral molecules also nucleophiles. Neutral molecules. How can you find out nucleophile? Neutral means what? No positive, no negative charges will be there. Okay. If positive charges are there, electrophiles. If negative charges are there, nucleophile. If it is not there, so how can you find out? Lone pair. So if lone pair of electrons will be there, lone pair of electrons will be there. Lone pair of electrons. Here oxygen is a lone pair. Oxygen is a lone pair. Lone pair of electrons will be there. If lone pair is present, those are called neutral. Lone pair is lone pair will be there. So there are unsaturation compounds also. Unsaturation compounds also neutral molecules. It means neutral molecules means what? Nucleophiles. They will come under nucleophile. So double bond, okay, double bond, triple bond, benzene double bond will be there. They all are all nucleophiles. They are all nucleophile. Okay. Here electrophile will come and attach to this one. So here organometallic compounds. Organometallic compound, metal should be there. If metal is there, nucleophile. Or MgS. This is called Grignard reagent. This is R2CD, R2 zinc, Li. So these are metals attached with the carbon chain. These are all comes under nucleophiles. You have to remember. For nucleophiles, negative charge species and ampident nucleophiles and neutral molecules. Neutral means among this neutral, three types are there. If lone pair of atoms are there, those are comes under neutral, those are comes under nucleophiles. Coming to this one, unsaturation is will there. Unsaturation is there means double bond, triple bond if there. So double bond, triple bond is what? They don't have positive charge, negative. They should not have positive and negative charge. If they don't have positive and negative charge, they will come under nucleophiles. Coming to this one, metal is attached to carbon chain or halogen or whatever it may be, halogen or carbon chain. Those are comes under nucleophile. You are getting my point? Okay. You have to remember and pick up in your notes, write in your notes, copy. Okay guys, next one here, what happens, some examples will be given, which one is electrophilic, which one is nucleophile, you have to remember. So here types of, what is it called, types of attacking reagents are electrophile, nucleophiles, free radicals. Free radical we didn't told, why? Because free radical means, you know, CH3 free radical, one electron is there, it will attach to another free radical. So it is less number of carbons, so you don't no mention here. So here coming to this point, what happens here? This is electronegative charge, so it will get negative charge. It will get positively partial charge. This carbon is central metal, it is. So it is positive charge. This is called electrophile. Positive charge means electrophile. Electrophilic carbon. Here this will get negative charge. It will get positive. It means electrophilic carbon. Here coming to this one, chlorine is attached to this one. This will get positive. It is electrophilic carbon. Okay. Here MgBr. MgBr means metal attached with carbons and what? Metal get positive charge. It will get minus charge. Minus means almost, you know, nucleophile. Nucleophilic carbon. Next one. So you have to remember guys, if stability and charge is there, stability is inversely proportional to charge. If minus charges are more, stability will be decreases. If positive charges are more, stability will be decreases. You have to remember that one. Okay. Next we go for new concept. Okay. Up to here, electrotypes of electrophiles, nucleophiles, free radicals, and order whatever it may be, we studied. Next we go for, okay, time is too much. So up to here we are stopping this lesson. I mean we are stopping this video. We will meet with new concept in the next video. Okay, these are the very important. Don't forget. Okay, so okay guys. Okay friends, please subscribe my channel and share to your friends. Okay, thank you. Okay, thank you. Bye bye.